Okay, good morning. My name is Per Carling. I work with EQUA, and today I will give this webinar about the IDA-ICE Addin Azure 90.1. I'm a civil engineer and I've been working with EQUA since 6.5 years. I'm the CEO of EQUA Solutions Sweden, and we are typically busy with IDA-ICE related work, testing, user support and training. But our group also do simulation work for building projects as well as monitoring in real buildings. We have been developing this tool for several years, and even though it has been used in around 150 LEED projects so far, mostly in Finland and Sweden, we have kept the beta label until this week, but today we will release this product. And for those of you that have used the tool, it will be possible to upgrade it from the portal. I will present a short background and then do a demonstration of the tool. And then for those of you that want to ask questions, you can do that in the end of the session. Just to give some background, LEED is big, as you might know. Around 60,000 buildings have been registered in the USA. Europe is a smaller market, but here are some graphs of the cumulative LEED registrations for some of the countries where IDA-ICE is used. Might not see the figures there, but you can see that the slope of the curves are quite impressive. So I think it's a reasonable guess that we can expect more projects to come in the future. The energy credit in LEED is very important. It has a heavy weight, and the method to be used is described in the standard Azure 90.1 Appendix G. The Azure 90.1 Appendix G describes the building performance rating method. And it's basically a comparison of two energy models, or actually the energy cost of two models. The actual or the proposed building model and the reference baseline building model. The baseline building model is defined in Azure 90.1 Appendix G. And it's a lot of things to keep in mind, a lot of details there, but I think you can come pretty far if you think of it as the comparison between these two models has to be fair. You have to use the same simulation program, you must use the same weather data and the same energy rates. Also, you have to have the identical geometry of these two models, the same space usage, process loads and schedules. Also, the quality in some sense in both buildings has to be the same. So the air quality and the thermal comfort must be comparable in those two models. To model the baseline building is quite a challenge. I think all of you that has tried agree with me on that. What you do is that you start with the proposed building model and then you transform that model into the baseline building model. And as I said, a lot of things should be the same, but here's an overview of the parameters to be changed between those two models. And there are a lot of variants, especially when it comes to the HVAC systems. So I have a list there of the HVAC systems that are used in the baseline building model. But for the building envelope, you replace the U factors and the solar factors based on the climate zone. For the window and skylights, you reduce the ratio down to given figures from the standard. And you model it the simulation model in 4 directions, and you use the average of the result for the 4 directions. For lighting, you replace the lighting power densities in the proposed building model by values stated by or prescribed by the standard. The HVAC system should be selected based on usage, number of floors, floor area and heating source. And there are a lot of detailed requirements on the equipment, and the equipment has to be sized, and when you simulate the model, you need to take into account both full and part load efficiency of the equipment. There are a lot of different rules, and then to the rules, you must add some exceptions, and keep in mind that those can happen. So for example, in this list or in this table, you can see system 1 is a package terminal air conditioner. It should be used in residential buildings. You should use one system per zone, and it's a constant air volume system with DX equipment for cooling and a fossil fuel boiler supplying heating coils. It's package terminal air conditioner. So that's one example of system used in the baseline building. I will come back to system 7 in a minute. Oh, it's here. So system 7 is quite common, at least in Scandinavia. You can see, probably recognize the icons. There are fans, it's a heating and a cooling coil, an economizer, and a heat recovery device. And then for zone control, you use, for the heating case, reheat coils. So you measure the temperature in the zone, and then a valve is controlled to maintain the set point of heating in the zone. And during the summer case, you use a conventional VAV system. So you increase the flow rate if the temperature goes above the cooling set point. So this is the basic system 7, but not all this equipment should be included in all cases. So there are some rules that applies and decides that you have to apply, and decides whether this equipment should be part or not. So it's quite tricky. Now the purpose of this webinar is to inform you or bring the good news about our Azure 90.1 add-in, which will simplify this task considerably. So what happens is that you use a building template either for the Azure 90.1 2007 or 2010 standard. The software automatically generates the baseline building. It auto-sizes the heating and cooling equipment, runs annual simulations for 4 directions and averages the result, and it automatically generates reports for LEED. So now I will do a demonstration, and I will start eyes, and I will start with the building template, and as you see, you can select either 2007 or 2010. I think from this month and on, it will no longer be possible to register projects under LEED version 3. So from now on, 90.1 to 2010 will be the template you will be using. So using that template does a few things. Most important, it sets up a number of energy meters that has names and measure things so that it fits with the reporting structure on LEED Online. So I will create a small building. It's actually rather ridiculous because I want to demonstrate, I want to make a full simulation and demonstrate reporting features and so on. So I want to make this model while you are looking. But we need to make it quite simple then. So what I start with is that I copy and paste a number of zones, and then I rename them. So this is an office room, and this is a hotel room, and then we have a server room and a storage room. So the building is quite diversified, as you see. And then we have a garage, which is warm. And then we have finally a garage that is cold. So it's yeah, a boring building, but for the purpose of this demonstration, it will do so. We need to fix some values. First of all, we need to remove the cooling in the storage room. So now I'm doing the proposed building, but this will be the basis for the baseline building. I remove the cooling in the garage as well, and in the cold garage I remove both the heating and the cooling room units. Also, I need a second air handling unit which will supply the cold garage, and I remove the heating and cooling in that air handling unit. Sorry. Like that, and I also need to remove some energy meters because it's no longer possible to measure any heating or cooling in that system. So let's select the air handling unit 2 for that, or the second one for the cold garage. And then we should try to give some reasonable values for airflow rates. So let's say 1 liter per second and square meters is not unreasonable for office and hotel, and for the garage it's rather okay as well. And then for the server and storage room we'll use 0.35 liters per second and square meter, which is typical value used in Sweden. We have no occupants in the server and storage room, and not in the garage either, I think. And for the lighting we will have a pretty low 2 watts per square meter in the garage. No lighting in the storage and server room. Maybe 5 watts per square meter in the hotel and 7 in the office room. And for the equipment, let's say we have 6 watts per square meter in the hotel and 3 in the hotel, and then storage, no equipment, not in the garage either. Like that. And then for the server room, let's say we have a 2000 watt computer. So, and then we should probably give a reasonable schedule now. I will use the same schedule for all rooms, even though it's not really reasonable to compare a hotel room with a office room. Paste like that, and maybe the equipment in the server room should be always on. Like that. So now we have a building that is fit for this demonstration, I think. Maybe we should go to the floor plan and distribute the zones as well. So this is the cold garage, and then we have the warm garage, I think, and then the storage room, and the server room could be there, and the hotel room there, like that. And then we remove the internal windows, like that. So let's go to the 3D view. So a ridiculous building, of course, but good for this purpose. Actually, we can remove the window in the garage and scale up the windows a little bit in the office room and the hotel room. Later on we will see that the software will rescale the windows down to 40% as prescribed by the standard. So maybe I should save this as well. Building 2. Okay, like that. Let's now turn to the ASHRAE tab, and then we can see that we can do some configuration work before we generate the baseline building. So by default, this building was located in this climate zone, which is okay for now. It's a non-residential building. Let's say that we can set that on the zone level later on. Now let's pretend that this building is large, even if it's not. So let's say it's larger than 5 floors. We have an electric chiller and a fossil fuel boiler. So the system 7 is the default selected by the program, but of course taken from the standard. So if we look at the office room, we can keep the system 7. If we go to the hotel, it should be a residential building. So that means that we switch from system 7 to system 1. For the server room, there's a exception in the standard that says if we have a very odd usage of this room, we should have another system, and then it's system 3 in that room. For the storage room, we select heated only. All these 3 zones are conditioned, meaning that there is sufficiently installed power to maintain set points. But in the storage room, we have less. That's true for the semi-heated case for this warm garage. But for the storage room, we have no heating and cooling. By default, the standard tells us that it must be heating and cooling in all zones, even if it's not in the proposed building. But in the case there are one option for some rooms where you can use the heated only case. And then you can see that the system used here was system 9. And for the cold garage, we use unconditioned space categories, and then we use the same type as the proposed case. So actually, if we go to the 3D view and check this, we can see that in this small building we will have 1, 2, 3, 4, 5 different systems in these 6 rooms. So it's a quite complicated building, even if it's small. One thing more I must add, and that is it's not reasonable to have the same system 7 for an office room in a garage. So we must add a separate system 7 in the garage. Actually, I do that by actually just changing the text string in this field belong to floor group. So let's just write additional system 7 like that. Now we will have a separate system 7 in that supplying that zone. So I guess well, we should change the minimum outdoor airflow rate as well for the different zones, and we can actually pick the values from the proposed building. So I just sort and then make a copy and then paste it in the configuration form. So there's some more things that we can do here. Actually, we can set the fan operation schedule for the different systems generated, and we can do a lot of more things that we won't go through now. We can change the framing of the windows and doors and skylights and so on. But I think this is good for this demonstration. Well, maybe we should use a space classification and talk a little bit about that. There are different methods for that. Let's select the space by space method, and then we can on the zone level select space category per zone that will govern the lighting power density of the zones in the baseline case. So we need to get, let's see, we have the office here, office enclosed, and then maybe hotel. Select guest room, and then server. Maybe we can select the electrical mechanical room. Storage room, I think there's a separate lighting power density for that, yes. And then we have the garage, parking garage. Paste like that. So now we set up system. Okay, so now I will press the run button. Maybe I should press save, and maybe I should lower the time step for output a little bit. You know that if you keep the default value 0, all time steps will be logged in eighties, which will create large results files. Not necessary now. I think I'm ready to press the run button. So now I'll press that run button, and what happens now is that the baseline building is generated. So what you see here is that 4 different instances of eighties started, and for each direction we will have a cooling design run and a heating design run. So, and during this cooling and heating design runs, sizing values or equipment sizes are snapped and put into the energy model. So automatically all the features are sized, and so that's made correctly. The low values now you see here in the monitor screen is due to the fact that we look at the same as proposed system. So we use this air handling unit where I remove the heating and cooling equipment. So that's why the figures are low. But actually what we can do is that when we are running these 4 rotations, we can also run the energy simulations for the proposed case, which will be needed in order to generate reports. So actually what we're doing right now is that we're running 5 different simulations, 1 for each direction and 1 for in the baseline case and 1 for the proposed case. Actually what happened more when I pressed the run button was that this baseline system was generated. So the envelope properties were changed, the windows were rescaled, the HVAC system were replaced according to the different rules in standard, and also these lighting power densities were set according to the standard. So let's see. Take a few minutes to run the simulation. Actually the baselines takes a little bit longer, I think, because it's more complicated, more systems included now, so the equation solver takes some more time. Have to wait till we get the result to look at the reports. Now, one important thing in this standard is a concept called unmet load hours, and so you have to report that the software was able to maintain the set point. So actually, unmet hours for heating and cooling is an important thing to check. So for the proposed case, it seems like we have no unmet hours. So the sizing of the equipment was okay. Now we use default figures for eighties, so that was not a problem. We're large enough. So now the simulation for the base cases are ready, and we can see here that all the 4 simulations are done and the approximate time they took to run. So you can also see that the time for the different rotations were a little bit different. So the longest time was for the south direction, and that probably is to be expected because there's more things happening on the south side than on the north side. Okay, we can now open the baseline, one of the baseline cases. Let's select this baseline 0 direction. Double click on that one, and then we can just check the 2 models. So you can see that the windows, now to the left we have the proposed case, and to the right we have the baseline case for the 0 direction. You can see that the windows were rescaled down to 40% as expected by the or stated by the standard. We can also, for example, check the constructions in both cases. So for the proposed case, we use default values, not very exciting, but for the baseline case, we can see that you have names on the resources used that are generated by the software and set according to the standard. Also, you can see that there are different wall types between the semi-heated, or sorry, the conditioned zones and the semi-heated and non-conditioned zones, something that is stated by standard. Also, we can check, for example, the lighting power density in the proposed case and in the baseline case. Lights like that. So you can see the values have been reset based on the tables in the standard. We can also check the advanced level. I don't know how many of you have used that, but let's create the advanced level, baseline 0. So we can see there's a plant with a chiller and a boiler. The default system was system 7, and then both a boiler and a chiller is needed. And then we can see there's an air handling unit, system 7, so that's one of them, probably the one supplying maybe the office. And then there's a second one supplying the semi-heated garage. We also have the system 9, which is a simpler system without cooling for the heated only zone. And we have the same as proposed system used for the cold garage. We don't do anything for that, for unconditioned zones. And if we look at the garage level, we can see the cold garage doesn't have any installations. The warm garage has a reheat coil with a valve and a PI controller, and there's a PI controller controlling the VAV system. And then the storage room is supplied by heat and cool from the system 9, which is a central system. The server room has a system 3, a local zone-wise system with an economizer, a fossil furnace, and a DX equipment. And then the hotel room has a system 1, also a local zone-wise system. Economizer, or actually it's not an economizer because the damper positions are fixed. Heating coil and DX coil. And then finally the office room also has this system 9, so it's a reheat coil and a VV, conventional VV system. Finally, I would like to generate the reports, so we can close the baseline case, and then we can press this report button, and then we will have first an HTML report with some overview of the model, the simulation software used, and the weather file, heating and cooling degree days. We'll have some overview of the space types and the areas related to that, and then we will have a message on how many unmet load hours we have in the baseline, that proposed case. There's a strict requirement on not exceeding 300 hours of unmet load hours for the baseline or the proposed case, and it seems like we reached that requirement, so yes, unmet load hours compliance, yes. And then finally we have a table with all the results, both the energy figures and the demands for the 4 different directions of the baseline, and also the average and the proposed building results as well, based on energy meter or end use. So these are figures that can be copied and pasted into the LEED submittal form on LEED Online. Second, we have an Excel report, which is based on something called table 1.4, which is a resource on LEED Online. So we try as good as we can to fill in this Excel sheet with figures from the model. We do this for the baseline case, which we are in control of. The proposed case is a little bit more difficult for us because it could be anything the user had created. So we have something for the envelope and something for the shading and fenestration, for the lighting. Some values are given, areas and lighting power density, equipment and so on. And then, for example, airside HVAC details. We have the different systems named as in the model, and we have total cooling capacity, total heating capacity, different flow rates, the fan power, and also pressure drop adjustment, something we didn't talk about, time for that. And also the water side HVAC details we feed in the baseline information as good as we can into this Excel sheet. It's up to the user to complete the proposed case and to check it that everything is okay in this Excel sheet. Well, I think I'm pretty much done with what I prepared to say. Now it's possible, if you want to ask some questions, you can raise your hand. I think there's a button for that in the software. So please don't be shy, but ask your questions and we'll try to answer as good as we can. Okay, I think Anders Fremling has one question. Please.
Yeah, hi.
Hi.
I'd like to ask if I have an existing building which is renovated, then I don't have to make all the four baseline cases. Just need to have one baseline case. Is that possible?
Yes, well, I guess we don't have a separate button for that, but I guess it's just to use this run button and then just use the values from the baseline 0 case. I think would be possible. Yes.
Okay.
Yeah.
Oh, thanks.
Yeah, thanks. Good. Kulandavel Mutusami. You wrote a question, how easy it is to model buildings of different form. I think that's more a general IDIs question. And well, I mean, basically what you can do in IDIs is that you import either some IFC file or you can import drawings or pictures and edit the building yourself. So it's possible to edit this building, of course, and do any format or any form of the building as you like. You can also import well, IFC files, as I said, and automatically generate the building. Yeah. Another question is, are you planning to have a plug-in for the energy-related topic in BREEAM? From Eirik Hordnes in Norway, I think. Actually, as far as I understand, BREEAM International allows you to use Azure 90.1 as one option. And then you can use this tool for that purpose as well. So it's not restricted actually to LEED, but it could be used for BREEAM as well, because it's actually Azure 90.1 added, not a LEED add-in. I think also BREEAM has national adoptions. So for example, in Sweden, there's a BREEAM Sweden manual that adopts to the national building code. Okay, a question from Samer Hassani at Sweco in Sweden. How is it possible to fine-tune the sizes of the baseline room units? It's a good question. What you can do is actually when you do your proposed building model, the sizing runs will be made together with the information under location. So for example, if you are looking at the heating equipment, the sizing case will be use the location form and the values or the design data in that form. So what you can do if you want to have larger equipment, then you can change this dry bulb min temperature, for example. Then you will have a worst case for the heating design, and then the equipment will be larger. That's one option. One question from Vin Huyn, asking, the baseline heating and cooling capacities are auto-sized based on proposed capacities. Should you then run the heating and cooling demand simulation for the proposed first before run the baseline for orientation simulations? Well, actually, that's not really true. You design and size the proposed case separately using the model you built. The run button and the auto generation use the proposed properties when it comes to geometry, weather file, a lot of things like that, but it's separately sized as a baseline. So the sizing in the proposed case does not affect the baseline sizing, but it's done in the baseline models. So one question about if there will be a video to review afterwards. One person was a bit late here, so we will publish some video of this webinar, so you can look at it afterwards. Can you use daylight tab to get LEED points too? Question from Sara Jan. Currently there is no automatic feature for handling LEED daylight, but we have this daylight tab, and maybe I'm not the right person to answer, but I think that everything is prepared. Well, actually, I'm a little bit. I'm not quite sure, but at least one of the credits in LEED will certainly be possible to handle in the daylight feed application. Yeah, we have to come back on that one, I think. Kulandaivel Mutsusami, that he had some friends that told him that IDA had limited capabilities to model water-based chiller. Is it possible now to model different types of water-based chiller system? Well, actually, you can model any water-based chiller system in IDA. I mean, the default case is quite simple. So you will have a chiller with a fixed COP. You can set up a performance curve if you like that. You can also either use something called ESPO plant, replace the plant by a ESPO plant, and then you drag and drop the type of equipment you want to be part of your system. So for example, you can brine to water chiller, and then you can drag and drop, for example, yeah, different kind of equipment, and then you can size your chiller. You can give some rating condition, and then type of compressor, and then you will have a system with a chiller that has part load efficiency and variable performance depending on the temperature and the part load. So you can also check the plant model on the at the advanced level. So and then change, rebuild things as you like. And of course, you can always in IDA start from zero and have an advanced level only system, and then build your chiller, brine to brine chiller, drag and drop the kind of equipment you want to use, and then connect the system as you like. So I would say it's the rumor from your friend is not correct. You can build anything. So now we have a question from Rafal Gavlik. You can talk. We've unmuted you, so please ask your question.
Hi everyone. Thank you for voicing. Can you please explain where is the results for LEED certification? I'd like to find it in one place and check it. The building is ready for LEED, or should I change something to get the certificate? Some kind of data, where I can find it.
Yeah. So if I return to the model that I built, when you press this report button, you will have these two reports that I described, one HTML report with the overview and one Excel sheet with all the input data of the model. So that's those two reports are prepared for the LEED submittal form on LEED Online. Of course, you can always and that result is ready for just copy paste into the LEED submittal form. But then, of course, you want to check your models for to see that the result is reasonable and understand how it works and so on. Then it's just to open the baseline case, and then of course you can use all the standard reports, the time series, the delivered energy, the system's energy, and so on, and check the model and look for more. I know it's quite common that you have to do some input and output reports to support your figures on LEED Online, because the reviewer wants you to create some evidence on how the the model was doing. So it's always open possible to open the 4 baseline cases and scrutinize everything and generate reports and so on. But for the purpose of the LEED online submittal form, it should be sufficient with the result. Well, most of the result is created from these 2 reports, I would say, the Excel sheet and the HML report.
Okay, can I ask something more?
Yeah.
About does the software have a special tool to check is it LEED or not LEED, or what kind of LEED is? So a platinum or gold or silver. Those have the software a tool to show us the building have or can having a gold certificate or platinum certificate.
You know, LEED consists of several credits, different areas to be covered in this classification system. What we're talking about now is one of the credits, the energy credit, EAP2 EAC1. So for that credit you're supposed to use this Azure 90.1 method. Actually the tool takes care of the building performance rating method described in this Azure 90.1 standard and gives you the result for that credit. If you want to include the entire LEED system into I mean the software isn't prepared for that, and that's a lot of different credits that takes care of I mean the distance from the building to some transportation system, a lot of things. So that's not the suitable place to do that in our software. It has to be you have to report this up to LEED Online and then use their tools to compile the project and decide the rating. Okay.
Okay, I understand. I understand. Thank you. And a completely different question, just quick, about the system 7, system 3. Is it the default systems that is built in the software I can only choose, or is it the system 7 or 3 I can rebuild it?
Actually, the software will decide depending on your selections. So let's say you switch from a non-residential building to a residential, then the default system will be system 1. For example, turning from a fossil fuel to electric heat, there will be system 2. This is stated by the standard, and so you select the type of building you have, and the software will select for you the right system in principle, and then you will have some exceptions to that. So you can select, for example, for the server room we selected system 3 because the server room is used in quite a different way than the rest of the building. So then we need to add a separate system. This is stated by exception G311 or something. So you will get a lot of help to select system. So that's true. But then, I mean, of course, you can always open the model, the baseline building model, and then at the advanced level do a lot of things. Then it's starting to get quite tricky. Then you really need to know what you are doing. So you can yourself rebuild things and change things, of course. But then you need to really know what you're doing. Okay.
Okay. Thank you.
Thank you. Johannes Gelrich, which is really adequate, I think. He's saying, as far as we know, the section 1.4 table has been changed to the minimum energy performance calculator. Will you adapt the report to this new form? And if yes, when will it be done? I won't promise anything here, but we know that. Actually, it's quite tricky for us to make these Excel reports. They are if you think of it, they are kind of conditional programming, so they are changing depending on what you select in different checkboxes and so on. So it takes a lot of time to figure out where we should put the right value. I know there has been one initiative reporting result electronically to some portal, and we have been discussing maybe going in that direction instead. which I think would be even better. But I can't promise anything right now, but we will for sure continue to develop this product because we see that there's people want to have it. I guess we will look into this this new Excel report. Sure. Yeah. Question from Hong Nung Nguyen. So the baseline is created to meet minimum requirements. I want to know which aspect is considered to be the most essential here. I meant the model will try to meet what first? The lighting, for instance? Well, I mean, it's when you read the Appendix G, the building performance method, rating method, it's obvious that the standard tells you how the baseline should look. So we can't really influence this, but we try to generate the baseline as correct as possible according to the standard. All the values requested by the standard is set up in the baseline case. I think it's probably up to you as a user to try and check and see what parameters are most important for energy efficiency, for example. But the software is there to use and try and test. Yeah, we had a question here about how to build the model from scratch. Maybe I can show quickly. Just creating from an IC file. I have a small office IC, and then I import that to the well, actually I should have started with we can do it anyway. So I import the IFC file into IDIs and create geometry automatically. This is the way we try to do it in all projects. If there's a 3D CAD model, it can be exported to IFC format. So actually you could import this. This model was imported, but currently there are no zones in computational zones in this model, so I need to insert them. I can click new zone like that, and then IDA will populate the model with zones according to the spaces in the IFC file. So looks like that. And if I close the IFC model, or then we have a ready-made model there. So that is how we typically want to do it when we create a model from scratch. Yeah, that was a question about that. Okay, seems like we are running out of questions, and also we are running out of time, I think. So we said 45 minutes and we're a bit more than 50 minutes now. So maybe we should finish this webinar then, and thank you a lot for participating. Okay, see you all. Bye-bye.